Hey everyone, here's a little project I did last night that some of you might find interesting. I replaced the PS2 keyboard with a serial keyboard. So here's a little demonstration of how that works. First I turn on the two systems. The Tandy Model 102, the first thing I got to do is run its little built-in telecon program. And then I do F3 to check stat, make sure it's still at 300 baud. Then F4 to actually start the terminal. Here we go. I just typed the list command across the serial port from the Model 102 over to the X16. So now I'm just doing a little hello world. Seems to all be working okay. Alright, so let's just do something new from scratch, a new little program. I got a program in mind just to do, color some pixels across the screen. So I'll type in a little basic program here. For those who don't know, the random 0 initializes the random number generator itself. You still got to assign the result to something. But random with the dot gives you a random number between 0 and 1. Screen 80, graphic screen 80, is just a standard 320 by 240 resolution. So yeah, all this is being typed from the Model 102's keyboard across that serial cable, received by the X16 and pushed into the kernel and interpreted. And yeah, the program works. Just drawing random color dots across the screen. So again, to show how it works from the top, on startup I set up the X16 to load this little interrupt service routine that starts listening to the serial port, and anything it receives pipes it over to the kernel. So all that's a little straightforward. Here I saved the program earlier and I'm just reloading it, showing that that still works. I was thinking we could replace the serial cable with Wi-Fi modems themselves, and finally get a wireless keyboard. And that would work, but we'd have to find a way to get 5 volts over to those Wi-Fi modems, so we'd still have a cable to deal with there. So I think next up I'll go a little bit through the code and kind of explain how this works. Alright, so I didn't know what to call this. I just called it Commander X16 serial DOS. So I just have some startup, clear the screen, and just to make it look different than the boot up screen from Blue, I put white on black. All of this mixes in another project I did called the SEMIBIGFONT, and that draws that large start at the start of the program. So this is all just kind of optional. It's just cosmetic. It doesn't really necessary to make the program work. Here's the word that whatever you want it to say on startup. But you put the word in, then just say, okay, draw it. So it's just a cosmetic effect. The more important part, down here, from another project I did, the basic terminal, and this is where it initializes the serial port. Since I'm going to unplug the PS2 keyboard, the users aren't going to have any way to type things on startup, so I have to hard code and make some decisions, and this is just the port I picked on the serial card. And I just chose 300 baud just from experience. Most people, they can't type faster than 300 baud. I mean, maybe we could use 600 or something, but it's not really necessary to go much faster than that. The Tandy Model 102, can't really even push out keys that fast. So this is boilerplate stuff, initialize the available baud rates, but in this example, we're just using the 1 baud rate. Initialize some placeholder variables for the registers of the serial card that we use. And so initialize the serial put input handler. That's not the interrupt routine yet. And then initialize the actual serial card. So we'll get into those in a second. Here initializes the actual service routine. So I'll go over that in a moment. Then to initialize the actual serial port, this is kind of one of the important things. To initialize it to the 8 data ports and 1 stop bit. If you're in a situation where you need something else, these are some other configurations that you can use. But we basically got to initialize the serial port to what baud rate we're working at. For some reason, I configured it to use like only 14 bytes in the first in first out buffer. No particular reason why I was doing that. I think I was just testing something in the early days of the serial port. Again, this is just all the dividers for the serial port. We're just using that one right now. This is all that code that I said, just cosmetic for writing the large version that I call the SEMIBIGFONT. So I'm going to skip that. It's interesting, but it's you could take all that out, and this interrupt service routine would still do what I want it to do. For loading up inline assembly in BASIC, this is just a little function I use. You do a restore on what set of data sequences that are going to have your machine language. Just read them in sequence. Look for 999 as the last value. When it encounters that, then you're done loading it into whatever address that you wanted to put it at. Read the data value, poke it into the address, increment the address. So that's pretty straightforward. So here's the main interesting part. So I have this blob that I get allocated into that golden RAM on the Commander X16 at address and hex 600, 0600. And this part, that was for something else I was doing earlier with the interrupt routine. I was storing a counter of how many times the interrupt is going off. Right now I just store 0 there. I may come back to using that in the future, but right now this address 400, which is part of the golden RAM, the start of the golden RAM, is not really used. But the 2 bytes after that I do use. Down here, so let me back up a little bit. I am using the counter on the VIA2, which is only going to be on the X16 dev board. It's got 2 VIA chips, and I'm just using the counter on the second one. And so this is kind of boilerplate code to initialize the counter on that. The interesting part here is this is the counter value that I used, 1030. I didn't know how long I needed to wait to pull the keyboard. Well, not the keyboard, pardon, the serial port, what's coming across the serial port. And so that's just what I started with. I couldn't really find how fast the via increments. I'm sure that's online somewhere. And it's probably maybe proportional to the clock rate. But in any case, this is a number I came up with that worked for me. I may experiment and see if I can reduce that or increase that. If you're running this at 300 baud, you probably want this value to be as high, so you're just not running as many interrupts. You want to be efficient. So if you pick a good number, you can start doing other stuff in the background too. Otherwise, if you're pinging that serial port too often, you're kind of wasting time. So I may experiment with that and see how large of a value I can get on these, on when the interrupt's going to trigger. So like I was saying, the next 2 bytes after the 400 and 401, I store the current startup interrupt service routine. And just from experience, we know where the stock ones are. They're at 314, 315, so we make copies of those. I got to overwrite those addresses, the 314, with the address of the actual routine. So that's just, you write the address that I want, which is in this next little section of golden RAM, the 0500. So I have the main kind of thing to initialize it, hard-coded at 0600. I use 0400 for a little bit of data, scratch data, and 0500 is the actual service routine that I'm going to use. When the program starts up, loads up like a regular BASIC program, then you return back to it. When it starts up, way up here, I do a syscall to the handler initializer, and then I just return, but the program just immediately ends after that. So you basically, if a PS2 keyboard was still connected, kind of the operator of the X16 could still use the machine as normal. But meanwhile, you sort of have this remote terminal hanging off the serial port. That's the Model 102 in this case. So going back down to the next part, the actual service routine itself at 0500. And just the way this is arranged, from experience, you don't really have to push the registers onto the stack. They're already done for you when the system service routine was entered. Some boilerplate stuff for the VIA, just kind of, you don't want the interrupt, hitting itself. So you kind of acknowledge that your interrupt has been received or is executed. So like I was saying earlier, if you're going to use dynamic ports, or if you want to support users being able to plug in different ports, you would have to poke into this offset, what the address was corresponds to that port. So I used to put just 00 there. Then on startup, I'd kind of ask what port number or query for it. And then once I figure that out, you poke it right in there. But right now it's just hard coded. Again, so that on startup, the users don't really have to type anything on the X16. Now, once it listens to that port, and basically if it has 0, basically it hasn't received anything, it's going to skip over this part and just kind of run the end of the service routine. If it was something non-zero, then we call this routine the keyboard buffer put. And just to show what that is, right here, there's the keyboard put in built-in kernel routine in the system ROM at FEC3. And just taking a look at that, pretty straightforward. It's just going to put it straight into the keyboard buffer. And interesting thing, when I first did this, I tried using FFD2, which I call the character out. And for some reason, it would work. It would send characters, the alphanumeric characters, but the enter wouldn't work. The basic wouldn't respond when I was pressing enter. It seemed to be receiving it okay, so I'm not fully understanding that difference. Stefan on Discord, he suggested trying just using the keyboard put, and miraculously that solved everything. So that's why I'm using that keyboard buff put instead of the character out. And since we're handling the interrupts, we're responsible for pulling these values back off the stack and returning to the interrupt, the main interrupt. If we did get a 0, then we want to just go ahead and execute the prior interrupt service routine that we stored in the golden RAM. So one thing I do is I like to have the original Scratch assembly code that I was using off in comments just to kind of remember it. And there's this website that I like, the Masswork 6502 assembler. And so if I'm just doing a little 6502 assembly, I'll just put it in there on the source side, hit assemble. And one thing I like at the second pass, what it does, here's a first pass, but on the second pass, I like this part where it gives the equivalent machine code. Now, one thing you'll notice, you'll see a blank here, and you got to be careful of that. So when you're doing your jumps, the accounting's not going to be right. And so what I found to fix that is the reason it doesn't have these opcodes is these are 65C02 instructions that actually aren't available in the original 6502. So I know that they're 1 byte, and so I'm just going to, as a proxy, you just put no operations in there, just as placeholders. So assemble again. And now you can see in the second pass, the offsets are corrected here. So it'll put EA as the NOP, so you got to remember to fill those back in with what they're supposed to be for the 65C02. I haven't found a version of a website like this that properly supports the full 65C02. So just a little caution about that. Imagine most other people, they'll use task assembler or CA65 or something like that from command line, but this little website, if I'm just doing a few lines of assembly, I found it really helpful. Then in BASIC, you just do your data sequence, and it's got the opcodes right there that you need to assign into memory. So that's it, in a nutshell, how it's working. I combined 2 past projects that I did, the BASIC terminal and then some keyboard interrupt handling. Kind of put those two concepts together. The main thing for me was figuring out that I have to use this keyboard buffer put instead of the character out. So if you don't like any of your PS2 keyboard options, maybe there's some interesting serial keyboards. Or if you want to just roll like they did in the mid-70s, those teletypes were expensive and hard to obtain. And so one of the first keyboards, were serial keyboards, and you see a lot of those in the past. Around the Intel 8080 generations, the Sol 20, the Poly 88, even the Altairs, that kind of generation, 76, 77, thereabouts, you start seeing serial keyboards. Thanks for watching. Hope you learned a little bit, and catch you all later.